everyone, I Neha Thakkar, Assistant Professor at New LJ Institute of Engineering and Technology. Today we'll start the Unit 6 of DBMS, that is Storage Strategy. So we have already built up the database, right? So how it is going to be stored, or when we retrieve the data, how it is going to be retrieved, how much time it will take. So for that some concept will be used. So we'll today see the indices and also we will discuss the types of indices. So first we will start with the basic concept. For example, I will be having a one relation, that is instructor, as you can see in a figure. It will be having ID, name, department name and salary. So if suppose we'll fire query like what select star from a instructor, so it will display all the records. But whatever you have seen, that is in terms of table, but actually it is not going to be stored in terms of a rows and column in a memory. It will be in format of a file and it is going to be stored in terms of a block. So for example, if you want to search some particular data, or if you will be having some constraint on that, right? So you have to go through the all data, then you can find your data. But it will be stored in a sequential file format in a secondary memory. So you can see that in a figure. Suppose first record is there, it will be having a pointer to the second record. That means what? It's not like that all the data or a record is going to be stored in a contiguous block. It may be in a different block. So for that, the pointer is required for the reference. So this is our search key, for example, ID of the instructor. So if you want to find out some data, for example, the ID is 83821. So what happened in a sequential file, first it will be start from the first one and then it will goes to the second last and you will find your data. Sometimes it may happen that you want a search key to find and it will be not available in your table. That means you will not get any output. Then also you have to search for the entire data. So that will be the tedious task. That means it will take a more time to access. So we need some way to store the data in a format that it's the period or a time which will take to access the data, that will be a minimum one. So we are going to use the indices for that. So index is nothing but what? It is a one small table is there and normally it will be having two field. The first one is the search key. That means on which you are supposed to search the data. And the second field is what? The data reference. So it is a pointer to the record. So only in a index table, the search key is going to be stored. Now which search key is going to be stored, that depend upon the implementation, which index we are going to use. So main purpose of index is what? To optimize the performance of a database by minimizing the number of disk access that required when any query is going to be fired. So that is the main purpose or a use of indices. Now let's move to the types of indices. So the first type is a primary, or it can be also known as the clustering index. The next one is a dense index, then sparse, then multi-level, and the secondary, or we can say the non-clustering index. So first we will start with a primary index. So as the name suggests, primary, that means it will be related to a primary key. So the index whose search key is the primary key of the table, that will be used in a index. So as we have seen, the index is nothing but small table of what? A two field. That is the search key and the pointer to the record. Here we have already seen that ID is what? A primary key. So in a index table, this ID value is stored as a search key. So when you just fire a query, like if you want a data of some instructor is having the particular ID, so it will point to that row directly. So this is called a primary index. Next one is a dense index. So the dense index contains a record for every search key value in the data file. That means whatever the search value is there. For example, this is our table. For example, we have taken this ID as our search key. But the basic prerequisite for this dense index is what? It should be a sorting one. That means whatever the search key you have taken, the data must be sorted in terms of that search key. So you can see that here the ID are already in a sorted form. So this indices is also known as a ordered indices because it is in a sorted format. Now, whatever the search key is there, for example, we have taken this one, ID. So in a index table, there will be a entry, first field is all the IDs, and that will again point to each and every record. So in that way, the dense index will be work. But the basic thing is what? Whatever the search key is there, that should be a sorted one, and there will be a record of every search key is there in a index table. Suppose now just we are going to do the search key on a department. That means there will be a biology, computer science, and finance, history, like that. So the first step is what? It should be in a terms of a sorted order of this column. So it is now sorted one. You can see that the ID are not now sorted one. Now you can see that the table, the index table is containing a search key as a what? The biology, computer science. And you will be finding that there will be a entry for each and every search key. That means whatever the different search keys are there, biology, computer science. For example, the computer science is having 3 records. So only one entry is there. Now the pointer will point to the first entry of this computer science, and then the record, or we can say they'll be connected by a pointer or a reference. So once you will find the first one, you can access the remaining record which are related to the computer science. So in this way, the dense index will work. Now, the next index is a sparse index. So the difference is what? Than the dense index. The index records are not created for every search key. That means you can just keep some of the search key. For example, here the ID. Again, we have taken the ID as a search key. As we have seen in the dense index, there will be an entry in index table for each and every search key of the ID. Now here suppose it is a sorted one. Again, the prerequisite for sparse index is the search key or your data must be on a sorted form on a search key. So here it's a sorted one. Now it will be divided into some part. For example, from the first record to this one, it will be having to the first entry. That means if you want that one, just you require to store the first starting entry of the search key into index table. Then the next entry would be 32343. So that will point to there, and the third entry is this. So this entries that you can just access with the first search key. So in this way, the sparse index will work. Again, it will be also known as the ordered indices, as the search key is in a sorted form. So only the difference between dense and sparse is what? In dense index, whatever the search key is there, for every search key, there will be an entry in the index table, while in a sparse key or a sparse index, there will be a no entry for every search key. You can do the partition, and according to that, you can do the entry into the index table. Now we will move to the secondary index. So as we have seen in the previous one, if we can say the table or the size of the index table is going to be a larger one. Just we have seen in the previous example, it will contain only 9 to 10 records. But in real time, it is not like that. Your database, it's going to be a larger one. So at that time, if you are going to search anything So it will take a long time. So we don't want that. Or we can say if your index table is going to be a larger one, it cannot be fit into the main memory. So at that time, the secondary indexing is going to be used. This is what just reduce the size of the mapping. That means another level of the indexing is going to be done. And it is also known as the non-clustering index. As you can see in an example, right now we have just create a search key or taken a search key as a salary. Here you can see that the salary column is there. This is going to be there. It is not required to be in a sorted form. Now here the index table is going to be created on a salary column. So you can see that some salary are going to be repeated. So no need to store the separate entry for them. For example, 8,000. It is going to be repeated. So you can see that only both search key entry is there in the index table. Now it is point to some another level and it will be having two entry. So that two will be point to the separate record. So in this way, the secondary index will work. Now, the another one is a multi-level index. As we have seen the previous one that because of it is not going to be fit into the memory, the access is become expensive. You need to access so many blocks into the secondary memory. So again, what happened as the secondary index, it is having one level. But now you can go for a multi-level. That means more than one index is going to be there. So at that time, it is going to be what? Outer index or inner index. That means outer index is there. It is also known as a sparse index or a primary index. And the inner index will be your a primary index. That means whatever the concept we have seen previously, that is going to be used here in a multi-level, but the level of index is going to be more. So this will work in which way? Suppose you will be having the outer index, it is having some block, or we can say some pointer is there, it will just point to the block 0 here, then index, this is to block 1. So there are so many inner blocks are there. Again, it will having a pointer which will just move or point to the what data block. Either it is a 0, 1 or the whatever the data blocks are there. So in this way, the multi-level index will work. The example for multi-level index is, as you can see in a figure, there will be a roll number and the pointer. So this is 100. So again, this is what the primary index that is going to be in a main memory, and secondary level index that is going to be in a hard disk. So first is 100 which will point to here in 100, and again that is also having a one another pointer. It will just point to the actual data into the data block in memory. So you can see that the first is 100, it will be having whatever the roll number is there between 100 to 199. So that will be in a one block. The another is 200 starting address. So it will be having the another say block 1. The another is block 3. So in this way you can go for the multi-level index. So this is the thing how the indices is supposed to be work, how they'll use to store the data. And main purpose of indices is what? To just improve the performance or whatever the time is required to access the data, that is going to be a minimum one. Thank you for watching this video.